Hello everyone, welcome back to Wild True Learn. Last time we did a bunch of reinforcement learning tasks with genetic algorithms, which can do stuff and are very hard to teach. We saw some of that last time. Today, let's continue on to the next task, UFO recognition. Hey, please help me. Aliens want to kidnap me. I'm building a large station to keep an eye on the sky around my house, but the image recognition system does not work. I know that all the Martian ships have round shape and those from Venus are triangular. Please divide them into two classes. I must be prepared. Okay. Well, he didn't have time to finish his email, but he did have time to send his email, so I'm sure he's okay. Okay, decision tree shape. Okay, so this is just like the decision tree for colors, except now it's for shape, and it's slower. It's much slower than the colors. This node compares sockets' shapes with elements' shape. If an element's shape is equal to only one socket's shape, the element moves to that socket. If element's shape satisfies both conditions or none of them, it moves to a random socket. Yeah, just like the old decision tree. Okay, so this looks like just a tutorial, so shouldn't be hard at all. That should just work. Yeah, it is working, just going really slowly. Alright, next one, let's go on to this branch. Statistical sample approximation. Good morning, our scientific center needs help processing observation data. Please extract as much information as you can. This is so non-specific, just give us all the information. Okay, so red, blue, so it looks like we want to throw away all the green and throw away all the squares and the red triangles. We only need 75% accuracy, so I'm thinking we can fudge it a little bit. So if we do all the red circles plus just all the greens, we ignore, all the blues, we ignore the fact that some blue squares might get mixed in. That might be better. So let's see, blue, red. We're gonna send all the blues in here directly without any... Oh wait, we need something else. Right, we need to filter out the green. So we're gonna put blues in here directly. The greens are going to go into the trash can. And then do the same thing over here. Green goes into the trash can. Uh-oh. We're only allowed 4 nodes. Okay. So we need 27. There's no way we can get 27 with just, well, yeah, we can't get 27 with just a blue. If we mix in all the blue squares, the accuracy is not going to be 75%, so that doesn't work. Okay. How about this? Blue and green. We definitely want to filter out all the greens. Trash all the green. And then out of the blue, you're going to have some reds mixed in. So we're going to keep all the blue. All the blue still goes over here. We're going to, for the red, we're going to now sort by shape. So all the red circles can go in here, all the red triangles can go in here. Now half of the red is going to get thrown away by the first decision tree, but that should be okay, I'm hoping. We still have sufficient number of red circles to make up for that. Okay, cool. Shape recognition. Hello, our post office desperately needs your help. We have too many letters coming in from a number of countries. We need to sort them by postage stamps. Square shaped from Europe, round from Asia. At this moment, we only need letters from Europe. Can you make it happen? We need it desperately. Okay, so are we gonna trash all the letters from Asia? That doesn't seem like what a post office should do. Okay, that seems pretty easy. So it's just different shapes. We only need the squares, right? Okay, we can do a decision tree, but I'm thinking We've done this before. Circle, square, triangle, square. Oh, yeah, this one's pretty slow and we'll only have 29 seconds. Well, if it processes 1 per second, 29 seconds, it'll have time for about 20, let's say 28 items, and it should be okay. Let's trash this. Okay, yeah, we just took the easy route. I'm sure you can do it with 2 decision trees as well. Alright, next one, photo parsing. Good morning, we work for a construction company. We need to ensure that the windows we want to install are designed accurately. Please create a program for smartphones that could proof check our designs for potential mistakes. Okay, this one only wants green squares. So we can sort it by... oh, and if it's 60% accuracy, then yeah, we can just do all the squares. That's gonna give us good enough accuracy. Can we do that? Or in fact, if we do squares and triangles, oh right, we're only allowed 2 nodes anyway, so this might be what we want to do. Okay, so what we have here is all the triangles plus some of the circles get thrown away, and then we'll have all the squares and about half of the circles. So that's going to be about 15 items total, and out of those, 10 of them are square, green squares that we want. So that gives us about 60% accuracy. Okay, cool. Alright, we're gonna do the startup later. Right now we have a big branch over here that goes all the way over here. That looks interesting. Fruits and vegetables. Good day, we are the Plants and Color Company. We are growing a variety of plants and delivering them to distant countries. The conveyor selects fruits at different stages of ripeness based on the customer's location. This method allows us to bring products of required maturity and freshness. We want to improve the pipeline by using an algorithm that will determine the degree of fruits' ripeness before they are collected. Okay, this one wants all the blue, this one wants all the green, 90%. So if we give them all the green, that's not gonna be good enough. Yeah, it's just not enough accuracy. Okay, so let's sort by color first. We're allowed 5 nodes, so maybe. Let's do our standard setup for sorting the colors. And then the blue can go here directly without any kind of filtering. Green, we need to pick out all the triangles. So we have the decision tree. Decision tree isn't super great because we're gonna throw away some of the required items. So because 90% accuracy, maybe triangles and everything? Take all the greens. Yeah, we're gonna have to throw away trash, so that's gonna be our node limit. Green, we'll throw away some of the green triangles, and then the rest go over here. Let's test. Okay. I thought that might have been too slow, but looks like it worked. Okay. New Gen NVD. Hello, our lab RGB Vision is engaged in development of high-tech optics, and right now we are working on next generation night vision devices. We are going to introduce a new color filtering feature into our devices. We need to teach our processors to define and distribute colors according to certain criteria. Will you help us with this? Okay. Okay, so all the red and blue, here's a mixture of things, but mostly just squares and some circles. This one strictly squares. Okay, so this might be another thing where we just try to distribute the colors and shapes smartly so we don't need to process as many things. So looking at the blue and red, either one of the colors is going to fulfill the 30 that we need. Red has exactly 30 and blue has a lot more. So this one, if we take only the blue circle and squares, and we filter out all the triangles, then that's enough to satisfy this. So we have all the reds, all the blues, and if all the greens we just need to filter out the squares and put them here. That should be good. So I'm gonna just completely separate the colors again. Okay, and the other thing is blue we don't need filtering at all. And then out of the remaining ones, oh right, no. Blue we need to filter out the triangles, right? Yeah. So maybe I'll put blue in the middle, just so that we have 2 lanes for processing blue. Okay. All the reds we said we were going to put them here. That gives us exactly 30 that we need. The blues, I'll prepare a trash can. The blues we need to filter out the triangles to send them over here. So maybe I'll use a random forest again. That's an easy way to sort out all the shapes. Blue, okay, triangles, and other shapes go down here. We're going to do 2 of those in parallel. And finally the greens. Greens we said the squares. Okay, so we're going to do another random forest for the green as well. Yeah, random forests are really making things a lot easier when we need to sort 3 shapes. Okay, green squares must go here. Green circles we're going to put over here, and green triangles we'll throw away. Let's test that. Nice. Made it just in time. Okay. Candy production. Hey there, I run a small confectionery business called Nom Nom's Candy. The demand for our sweets has been booming lately, but all our candies are handmade. Needless to say, we are running behind schedule and desperately need to optimize our production. We have a conveyor that hopefully will help us with packing the goods, but it will need to be trained to distinguish sweets by their kind. Okay. Yeah, it's another mix of things, and we have 2 input streams now. Okay, let's see what we can do. This one takes all the blues, this one only takes blue squares, which must come from here because the other one doesn't have any blue squares. Reds, we have a mixture of everything from the 2 input streams, and green, you must separate the shapes. Okay, we're allowed 12 nodes, so I'm just going to start by sorting the colors first. And then we're going to make a copy of that. Okay, this seems like it's going to take a lot of nodes. Okay, so here we have, let me change the colors. Okay, and maybe even, Yeah, so this one I want blue to be in the middle to have 2 lanes. Green, and then this one, maybe green's in the middle because we have the most greens from here. Okay. On top, the reds, we need to just separate out the circles and triangles. That's pretty easy. Trash, circles go in here, triangles get trashed. Okay, green, we also need to separate out circles and triangles. Circles go here, triangles go here. Now let's do a copy paste. The next green lane does the same thing. And the blues, we can feed them directly over here. We don't even care about the shape because we don't have any blue squares here anyway, so they must go to output stream 1. Alright. Down here, the red. So again, we're gonna do that for the red. Okay, we're approaching our limit for the number of nodes, so we gotta be careful. Blue, yeah, blue we're gonna need to start filtering. So we're gonna do the random forest to get the different shapes. Blue squares go here, and that's specifically something that we want. Blue, or actually, do we even need that? Yeah, no, because we have plenty of green circles over here. So if we're already feeding all the green circles down here, that's enough, actually, really. 35 green circles. Okay, so we may not need to filter the blue at all if we want to save on nodes. Let's just put all the blue here for now. And then green, we want to separate out the triangles. So let's do a random forest for the green instead. Green triangles, green everything else. I hope that's connected correctly. Nice. Okay, looks like we're completely done with this branch. Okay. Yeah, I think we have enough time to do the startup. Okay, we're gonna save first. Just in case. Tree. Mr. Cat's School. Hello, we are an online learning company and we prepare educational courses on our own platform. Have you heard of e-learning? We are growing rapidly and our main goal is to make education modern and personalized. To make it happen, we need an algorithm which will pick the best courses for each student based on their interests and goals. What do you think about this idea? That's good. Invest 3,000. Okay, so it's just the colors and shapes again. We need 100% accuracy. Okay. Just thinking about ways that we can optimize this, because obviously we can do the standard way, but why do that if we can simplify it? So I'm seeing green circles, but there's a very, very small number of green circles. So maybe I don't even care about the green, I'll just throw away all the greens. So this one will take all the red squares, and this one takes all the the blue. And maybe we don't even need the squares, we just want the blue circles, because there's way more of those. Okay, so first let's do the decision tree. We're gonna filter out all the colors. So we have more blue shapes to filter out. We said we're going to throw away all the greens, so I think I want blue in the middle. So we have 2 lanes for processing blue in parallel. Green we're just going to throw away, because we don't care about the green circles, there's not many of those anyway. red, we want specifically the squares. So we can do a sift. Squares. Sift is a little bit slower than the decision tree. 0.8 versus a little bit more than 1, but it gets us exactly one shape immediately. Whereas the decision tree, we have to kind of do 2 layers if we want to filter it properly. Yeah, and I think that's all we can do for shapes. We don't have the random forest in this case. Okay, red, square. Go here, red, everything else, get trashed. And then blue, we need circle and square, but we said we don't really care about the square, so we can do decision tree here. Circle and triangle, we definitely want to filter out all the triangles, so circle and half of the squares go in here. Triangle and the other half of the squares get trashed. And then we're going to hook it up to the other blue route as well. Green get trashed. Okay, looks like that's okay. Release. Okay, so let's see. Yep, we're doing okay. Okay, now we're losing money. Let's just process more users. So just something like this, as we usually do. Patch it up. Okay, yep, now we're making money again. Okay, now we're not serving that many users, but again, I'm not going to patch it again because every other startup we've done before, it only pretty much takes two what do you call them, production lines in parallel. If you try to parallelize it to 4 lanes, then it doesn't actually help. So I'm just going to continue like this until we lose money. Like, this is crazy. 103,000 balance, and our stock is already worth 31,000. This is like double our existing money. We can afford that really expensive thing now. Okay, we're starting to, yep, get toward the end. Okay, and this is it, 45k. That is crazy amount of money. Okay, let's check our inbox. I think we have a new email. Yeah, mail from lottery committee. Did I win the lottery? Hello, you've registered in the prize-winning lottery prize pool. We're happy to let you know that your registration number won in our last drawing. Congratulations, the money will be sent to the bank account stated during registration. Oh wow. Okay, I actually get cash. For a second, when I read the first sentence, I thought it was a spam, and or a scammer, and it was gonna ask me for my bank account information and blah. But yeah, this is real money. Okay, great. All right. Yeah, Tank Cat is still amazing. Okay, Seabay. Okay, we can buy a lot now. Bandhammer Miniature Cat Marine. This we have to get. Or click Q903, comfort and usability. That's a new mouse. Mood poster. Oh, I get it. Mood, yeah. DQDD. Grunge haircut. Stylish modern, sadly no one can see it. And messy hairstyle, the main thing that isn't within the mind. Nodes, we don't have anything. Hardware, we can buy more. 16GB RAM, increased socket processing queue. J-Intel Elrion CX367UP decreases server cost. And GVIDIA Colossus 9 increases nodes work speed. Yeah, these are all great to have. And then cats. We can either get Wasteland or the Moralist. Apex of the Evolution or Courier's outfit. This one's more expensive, so I'm gonna get this one first. Moralist. Okay, let's look at what we have. Oh, this is a moralist. That looks really cool. Look at the tail. Okay, here's have a bunch of machines. I'm not here, so I guess you can't see the haircut. Here's our cat statue. Here's our new mouse, tambourine. Have a bunch of machines here. This is the machine we used in the story segment to detect our cat's emotions. Here's the raccoon friend again. Alright, so yeah, I think I'll end the episode here. I don't have anything else to say. Next time we come back, we will continue on to more tasks. Thanks for watching. See you next time.